So yesterday we talked a little bit about absolute value, the parent function of absolute value. Today we're going to take it a little bit more in depth. So we learned yesterday that the absolute value parent function is y equals the absolute value of x. Okay, that's my parent function. I can take this and transform it many, many different ways, and that's what we're going to talk about today. So this right here would be my graph for the absolute value function, parent function. Notice that it goes, my points meet up right here at 0, 0, which is known as the vertex, which we're going to talk about a little bit more in depth. Wherever the two lines meet in the middle, that is your vertex. So what's my vertex right here?
0, 0.
So my vertex for the absolute value parent function is 0, 0. Okay? The axis of symmetry would be like if I were to take my paper and draw an imaginary line right through here and fold it together. They would lay on top of each other and be identical, right? So my axis of symmetry is whatever this line right here is. So my axis of symmetry of this would be the what? Just the y-axis. It won't always fall that way. It's going to be different on every graph, okay? But my line of symmetry right here, sometimes it's called line of symmetry instead of axis of symmetry. My line of symmetry is the y-axis. That's where I can take it and fold it to make the exact graph on the left-hand side and the right-hand side. So the next graph, that right there, I don't really need that. So let's talk about one. The best way to get these problems is to actually work them. So it says, what is the graph of the function y equals the absolute value of x plus 2? What is the graph of the function y equals the absolute value of x plus 2? Well, first let's graph our parent function. What's our parent function? Y equals the absolute value of x. Everybody agree? That's our parent function. I'm going to come over here and I'm going to graph it. That's my graph for the absolute value of x. I start at 0, 0. That's my vertex. And notice, the absolute value function goes perfectly through these little crosshairs right here. Does everybody see that? That's how you know that it is the parent function. 1, 1 on the right, negative 1 on the left. Negative 1, 1 on the left.
So that shows it how your parent function is.
Yeah. Now, they want me to take the parent function, which is this one right here, and create this one. Well, what do I know I'm going to do to the parent function? I'm going to go up 2 times, right? So I'm going to take my graph, always start at the vertex. I'm going to take my graph and go up 2 and redraw it. That would be y equals the absolute value of x plus 2. Starting at 0, 0 on the parent function. This one wants to know the, let's go back to this one a second. I know the question. It says, how is this graph different from the parent function? In words, what would you say if we went from the parent function to this one? What would I do to it? Shift up 2. When they ask you how they differ, that's what they want. They just want words, okay? So the next one. They give us the graph, they give us the equation, y equals the absolute value of x plus 3, and they want us to graph it. Okay? Now, if I start at 0, 0, because I know that's my vertex of my parent function, what am I going to do to my parent function? I'm going to go up 3. 1, 2, 3. So it's going to look something like that right there. My pen's a little bit off, though.
So you always start at 0, 0?
Always start at 0.
So your parent function always starts.
For the absolute value, my parent function vertex is always 0, 0. So how does it differ from the parent function? Shift up 3. This is just a review of what we went over yesterday. If you want to look at it in Canvas, you can. So here's problem number 2. Now that we're going to combine some translations, okay? They give us more than just let's go up or down. They want to know which of the following is the graph of y equals the absolute value of x plus 2 plus 3. Y equals the absolute value of x plus 2 plus 3. Take a minute and look at it. Determine which one you think it is, but don't yell out an answer. Does everybody have a thought in their mind of which one it is? Okay, well let's look at this over here. What am I doing to my parent function right here?
Like you're, what's it called?
I'm going which way to?
You're going to the left.
Why am I going to the left to? Because it's a positive 2, I'm going to the left. Remember, it's backwards. Then what am I going to do to it?
You're shifting up 3.
Then I'm going up 3. Well, if I start at 0, 0 on any of these graphs, which one is going to be right? D. If I start at 0, 0 and I go back 2 and up 3, D is going to be my answer.
D.
Yep. I start at 0, 0 right here. It tells me to go back 2, and it tells me to go up 3.
Even if
That's
it is
my
a
new
positive,
vertex.
you still have to go to the left. I forgot.
Positive left, negative right. Remember that? Backwards. So what is the graph of y equals the absolute value of x minus 2 plus 3? Where am I going to start? 0, 0. I'm going to put me a dot right there because that's where I'm going to start. What does this graph tell me I'm going to do?
Go to the right 2.
So x minus 2 tells me I'm going to go to the right 2. Then what does it tell me I'm going to do?
Up 1.
And then I'm going to go up 1. And that's going to be my new graph. So now we're going to get into the stretch and compression, stretch and shrink. So what is the graph of y equals a half x? Y equals a half absolute value of x. What is my parent function? Y equals the absolute value of x. What am I doing to my parent function? I'm compressing it. Why? How do I know that I'm compressing it? Because a, which is that number right there, is less than 1. Okay? So if I compress it, that means that it's going to flatten out some. Okay? So this is not going to be exact, just to let y'all know. So if I come down here and go to 0, which is my parent function, and I compress it down about a half from that point to that point right there, that's what my new graph would look like. What if I would have given you this one? Would I stretch or compress? Stretch. So that one would have looked something like that right there.
And then a shrink would look like.
Whenever you're like shrinking it or making it bigger, do you move the vertex?
No, the vertex stays the same. It's just the lines.
How do you know how much to
Well, I know that if it's a half, it's going to be halfway between these two lines. And if it's 2, it's going to be a little bit further than a half. You just kind of have to guess around there. Other than that, you can get your calculator out and graph it and get you an exact graph.
So you're not gonna look for the exact.
Not when I ask you to draw them like that now.
What about on Math Excel? Like, how do you know how to do it on there?
We're going to work on Math Excel today when you come across one. Bring it up there. So here's my graph. We just did this one. I didn't know it was in here. That was the one we just did. Let's look at this one. This one's different. It says y equals negative 2/3 absolute value of x. Stretch or compress? How do I know I'm going to compress? How do I know it's less than 1?
It's a negative.
Because of the fraction. Now, not every fraction is going to be a compression. Know that, okay? But 2/3, if I take it and turn it into a decimal, what is 2/3? 0.6 repeating, right? Greater than or less than 1? Less than 1. So I know this right here is going to be a compression because of that. The negative has nothing to do with that. The negative is totally separate than the number, okay? What does the negative tell us we're going to do? We are going to reflect it. This means reflect. That means compress. Remember, the negative and the numbers are not together in this particular thing. The negative means I'm going to flip it. Then I look at the number, just A, to determine whether I'm going to stretch it or compress it. So this one right here is going to be flipped. So it's going to be something like that right there. Somewhat. It's not exact, but it's close. This is the new concept. General form of the absolute value function. Here's you another formula that you need to know. Which looks a lot similar to things we've been doing, right? Now we're just putting some letters with them. So I've got y equals a times the absolute value of x minus h plus k. Y equals a times the absolute value of x minus h plus k. You need to know this. This is important. Another thing. What if I have a graph and I want to find the vertex? How do I determine where the vertex is? Well, by this formula right here. The vertex is always going to be h and k. So if I'm looking at this formula up here, h and k are going to be my vertex. The other thing is called the axis of symmetry. The axis of symmetry is x equals h. And we talked about axis of symmetry a while ago. Remember, it's that line where if I take it and fold it, the graphs are going to lay on top of each other? That's what the axis of symmetry means. X equals h. Important information right here. You need to know this. If you know this, the problems will be easy. So let's look at a problem. It says, without graphing, what are the vertex and axis of symmetry of the graph of y equals 3 times the absolute value of x minus 2 plus 4? What am I looking for? We're looking for the vertex and we're looking for the axis of symmetry. So ultimately, we want to know what the h and k are for the vertex, and we want to know what x equals h is for the axis of symmetry. So I'm going to take this problem right here, and right up underneath it, I'm going to write down my formula. So I have a problem. I have the formula written down up underneath it. I need to determine what the vertex is. So what do you think the vertex for this problem is going to be? This is H, this is K. What would H be?
-2.
2. Here's your little thing with the absolute value bars. If this is -2, this is going to be +2. If this is +2, this is going to be -2. So whatever is in this absolute value bar, it's going to be the opposite when I pull it down here to the vertex. Okay? So what is K? 4. So I have my vertex, 2, 4. What would my axis of symmetry be? That would be my axis of symmetry. Because what is H? 2. That's just like saying X and Y. What is X right here? 2. So the last part of the questions ask, how is the parent function y equals absolute value of x transformed? So if I start here, how do I get here? That's what they're asking. Now the rule follows, you start first within the absolute value bars. What happens within the absolute value bars first?
You move it to the right.
So I'm going to the right 2 times. Now I'm going to go to the beginning of the equation and work my way back. What am I going to do? Stretch it by, because if A is greater than 1, it is a stretch. So I'm going to stretch it by 3. Then what do I do?
Go up 4.
Go up. So those would be my transformations. Right 2, stretch it by 3, up 4. This tells me to go right 2. This tells me to stretch it by 3. This tells me to go up 4. So my bottom problem down here is y equals -2 times the absolute value of x minus 1 minus 3. What do I need to do first?
Formula.
I'm going to go down here right up underneath it and write my formula. So I know that I don't mess anything up when I do it. So A, x minus h, plus k. So I'm looking for my vertex, and I'm looking for my axis of symmetry. So what would my vertex be for this problem right here? 1, -3. If this is negative, this is going to be positive right here. Then I have -3 over here, so I have -3 right here. That's my H. That's my K. So what would my axis of symmetry be? 1. My axis of symmetry is whatever my H is, which is 1. So then now they want to know the transformations. What transformations had to occur to get from my parent function to my actual problem?
Get to the right 1.
So I'm going to go to the right 1 time because I'm going to start within the absolute value first.
And is it a stretch because 2 is bigger than 1?
Correct. So I'm going to stretch it by 2.
Why not move it to? Because the negative is 2 to
So what does the negative tell me I'm going to do to it? The negative tells me I'm going to reflect it. So now instead of looking like this, it looks like this. So instead of making a V, it makes an upside down V because I've reflected it. And my last thing would be down 3. So now they give us a graph, and they want us to write the equation. Okay? This is all we have to go by. Right here is my graph, and I need to write an equation. There are three things that I need to identify, or two things that I need to identify first. First, I need to identify the vertex. Then I need to identify the slope. How would I identify the slope of this problem? How do you find the slope of something? Rise over run. That'll be the easiest way to do it. Then all I have to do is write the equation. Those are the three things that you need to do if you're taking a graph and actually writing out an equation. So let's look at the vertex. What would my vertex be? So I go over, if I start at 0, I go over -1 and up 4. So my vertex is -1, 4. Now I need to find my slope. How would I find the slope? Rise over run. You could pick 2 points and go through y2 minus y1 equals x2 minus x1. But rise over run in this case is way more simpler. I'm going to start at my vertex, and I'm going to go down and over. Either way, it does not matter. Okay? Down 1 over 1, 2, 3. So down 1 over 3. Why would it be negative? Because I'm going down. If I could have went down 2. It would have been 1, 2, and then over 1, 2, 3, 4, 5, 6. What would that reduce to? -1/3. So it doesn't matter how many times you go down or over. It should be the same thing regardless after you do all your reducing.
Wait, so so that's going to be your H and your K. So -1 is your A. Why don't you say X and Y?
Because the formula is H and K.
But you can just say it's understood X and Y.
Because there's already an X in the equation. You can't confuse them. So this right here is like your A, okay? That's what the slope is. So if I write down my formula, which is y equals A times the absolute value of X minus H plus K. Is that right? Plus K. So what is A? -1/3. Absolute value of X minus plus 1 because I'm taking the opposite of whatever that is. And then I'm going to add 4 onto it. That right there is my equation for that graph. Y equals -1/3, absolute value of X plus 1 plus 4. Now do you see why they don't name it X and Y? Because there's already X in it.
So you had a, what is that what is that up there at the 1, 2, 3? It says 1D slope.
ID.
Don't we use the same stuff formula we always use?
Y2 minus Y1 equals X2 minus X1. You could do that. You could come over here and get 2 points on that slope and do it. But with this right here, it's just easier to do rise over run.
But it looks like you're working it backwards from what we would do.
We are. So now they want us to do the same thing here. We have a graph. They want us to do the equation. What do I need to know first? The vertex. What would my vertex of this one be? 2, -1. If this is where it meets, I go over 2, down 1. That would be my vertex. Now I need a slope. How am I going to find the slope? Up 1 over 1, 2, 3, 4. Now I have a slope. Another easy way to remember this is if it goes this way, I know that it's going to have a positive slope. If it's turned this way, I know that it's going to have a negative slope. Okay. let's go over here and write our equation. What's going to go where A is? 1/4. What's going to go where H is?
2.
So is it going to be a positive 2 or negative 2? And then what am I going to put here? Minus 1. That's my equation. I started at my vertex. I went up 1 and then over 4. Always.
So you got your vertex to negative 1 from 0.
If I start at 0, right here, how do I get to the vertex?
Okay, so you have
Over
to always
2,
start at
then
0.
I always start at 0. Any questions? Any questions? Okay, let's look at these. So, 1 and 2, all they want to do is for me to find the vertex and the axis of symmetry. The first one is y equals 2 times the absolute value of x plus 4 minus 3. What would my vertex be?
4 and 4. No,
Negative 4 and negative 3. Why would it be negative 4? Because it's positive in here, so I need to make it negative. So it'd be negative 4, negative 3. What would my axis of symmetry be? Negative 4. Whatever my H value is my axis of symmetry. Okay? So if my H value is negative 4, what's my axis of symmetry? Negative 4. This one over here is a little bit different because what's the difference between this and this right here? It has a negative x in it, okay? Anytime you encounter one that has a negative x in it, whatever this sign right here is in front of that number, it's going to stay the same. So the vertex of this one would actually be negative 3, 9 because of that negative in front of that x. Okay?
So however the thing reads, so find the vertex of the axis of symmetry. So you have to go in order, find the vertex and then the axis of symmetry.
Yeah, it would be easier. So what would my axis of symmetry be? Negative 3. Correct. This one down here just wants to know if it's a stretch or a compression. So negative 7 over 2, absolute value of x. Stretch or compression? Why would it be a stretch? 7 over 2 is more than 1. Now do you see at the beginning when I told you that not every fraction would be a compression? Because 7 over 2, 2 divided by 7 gives me what, 3.5? 3.5 is higher than 1, right? What does the negative tell me I'm going to do? Reflect it. The next one is y equals 3 over 2 times the absolute value of x. Why is that one a stretch? Because 3 over 2 is bigger than 1. Any questions? Any questions?